All right, so first thing we're going to look at is the graphing form or the vertex form of a parabola. So you may hear it both ways. And that form is the form that we did when we did parent graphs, so the one with the h and k. So y equals a parenthesis x minus h squared plus k. So remember that a is what can vertically stretch it vertically flip it over the x-axis or vertically stretch or compress. For what we're doing right now, just we need to know if a equals 0, if a is greater than 0, the parabola opens up, which is going to look like a regular U shape. And if the a is less than 0, then our parabola is going to open down, which would be an upside down U. All right, and then you can make an xy axis on your paper, and we're going to put a point at 3, negative 4. So that's 3, this is at negative 4. And we'll get into how do we get more exact points later on in this section, but for now, just kind of go right 1 and up 1 from the vertex, left 1 and up 1 from the vertex. And then the other option is 2 squared is 4, so I can go right 2 from the vertex and up 4, so that'd be right on the x-axis, left 2 and up 4. So remember, that is our vertex right there. And remember, the vertex is always your min or your max. In this case, it's a minimum. And for us, it'd be 3, negative 4. Remember, the vertex is also the point h comma k. Okay, so when we go and write our equation here, this is opening upward, so our a is positive. So I don't have to put anything in for the a. You can put a plus if you want to. And then I'm putting a positive 3 in for the h, but it's going to look negative because it's a minus sign. And then we have the minus 4 at the end. So that would be our equation. This dotted line that's right in the middle here, this is our line of symmetry or axis of symmetry. And that is a vertical line, so it's always going to be x equals. So in this particular case, the equation is x equals 3. As we generalize it to all parabolas, it's going to be x equals whatever your h value is. So you can, up here, you can write x equals h. So our h was 3 here, so in this case, like I said, x equals 3 is our axis of symmetry. And the last thing you just want a quick reminder of is we're going to be looking at x-intercepts and y-intercepts. So where it's crossing the x-axis, right here and here, that's the x-intercepts. And again, that would be where the y equals 0. And then if I were to extend my parabola to cross the y-axis, that would be our y-intercept right here. Which is where the x equals 0. So today, besides knowing the vertex form, we're going to talk about how we can graph exact parabolas using the vertex form pretty easily. All right, so we come over here. All right, so these are the steps for graphing in the parabola in vertex form. Again, you can abbreviate these steps or write as much or as little as you want when you're taking your own notes. But again, if it's in this form, the y equals a times the quantity of x minus a squared plus k, this is what we're going to think about when we graph it. So first thing you're answering is, does the parabola open up or open down? Remember, if it is the a value is positive or greater than 0, it's opening up. If the a is negative or opening down. If the a is negative, it would open down. Yep. Opening up points up, opens down points down. That's opening up. So again, you're always looking at that number in the front, whether it's positive or negative for that first thing. Once you have that, we can figure out where the vertex is because we know that the vertex is the HK, and we're going to plot the vertex on our graph. Yep. All right, then the way we get more points is we use our parent graph table to help us get movements from the vertex. So our parent graph table is just y equals x squared. Y equals x squared is the simplest form of a parabola. And so if I square every x value from -2 to 2, I can get my movements from my vertex. So 0 squared is 0. That's our normal vertex for y equals x squared. -1 squared is 1. So that means I would go left 1 and up 1 from the vertex. +1 squared is also 1. And then -2 squared is 4, and +2 squared is 4 also. So you want to make sure you copy that table down. And again, this is the table we're going to use to help us get more points because it's the same pattern. We just are starting at our vertex now instead of 0, 0. All right, and then once you have that, we're going to look at our x and y intercepts. Find them if they're not plotted already. Remember, to find the y-intercept, you're getting the x equal to 0, and to find the x-intercept, you set the y equal to 0. And then you just kind of connect everything together that you have plotted. All right, so you see the equation up here is f of x equals negative quantity of x minus 1 squared plus 4. I also have our steps from the previous page up here. Again, you don't need to rewrite them, but that's kind of where guide us to where we're going. So first thing, as we see this equation up here, we want to see, does the parabola open up or down? Well, it's opening down. There is a negative in the very front. That means our A is negative, so this is going to open down. Okay, so it's going to look like this in the end. All right, then we want to determine our vertex. So we have to figure out our H and our K. What do we got? Five? Right. +1, and then this plus is +4. So remember, the H is opposite, but K is going to be what you get. So it's +1 and positive 4. So you can make an XY axis on your paper, try to scale it, and you're going to go right 1 and up 4. And put a point. That's your vertex. Now for the third thing we're going to do is we're using that parent graph table to plot some points. So remember, this was our parent graph table for y equals x squared. You copied it down before. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. That was our vertex. 1 squared is 1. 2 squared is 4. So this is our new vertex up here. So now I'm just using those movements from that point. So this is left 1, and since I'm opening it downward, it's going to be down 1 from the vertex. So here's my new vertex. I'm going left 1 and down 1. Again, I'm going down because it's opening downward. And then we'd have the mirror image on the other side. I'm going right 1 and down 1 also. And then I can go back to my vertex, and I have to go left 2 and down 4. So here's my vertex, left 2, down 4, right there. And then I'd also have to do right 2 and down 4 as well. And then do your best to connect the points. So we have it graphed. I do want to quick review how to go over your x and y intercepts, though, or how you find your x and y intercepts algebraically. In this case, depending on what the question asks, you can see where you're crossing the x-axis. You can see where it's crossing the y-axis, so you are good there. But just as a quick review algebraically how to do it, we'll do that right now. So when you have to do it algebraically. So y-intercepts, remember the x is equal to 0. So if I put 0 in for x right up here, that's the same as saying f of 0. 0 is the input to the f function. And I'm just simplifying the right side. I have to start inside the parentheses. 0 minus 1 is negative 1. Then I do exponents. Negative 1 squared is positive 1, and I have the negative in front. So this would be negative 1 plus 4, which is 3. So 0, 3 is our answer there. And if you notice, 0, 3 is where it's crossing our y-axis. So we're good. That matches what we expected. For our x-intercepts, that's where we're going to set the y equal to 0. So I'm putting the whole 0 in for that whole left side. And then I'm going to have to solve for x. And I'll solve for x by undoing. So PEMDAS backwards, I'm going to undo the addition subtraction. So I'll subtract 4. I'm going to undo the multiplication. So there's multiplication by negative 1. So divide by negative 1. So that would give me just an x minus 1 squared equals positive 4 now. And then we undo a square. How do you undo a square? Square root. So I'm going to square root both sides. That would cancel out the square, so I'm left with just x minus 1. And on the right side, since I wrote that square root, how many answers are we getting? We're getting 2 answers, so we need plus or minus 2 here. So that would give me x minus 1 equals positive 2, and x minus 1 equals negative 2. So when I add that, I get x equals 3, add 1, x equals negative 1. So as we expected from our graph, 3, 0, and then negative 1, 0 as well. Those are our examples. Now again, if it doesn't say solve it algebraically, or if you can clearly see on the graph where it's crossing, then just state them off the graph. But if it's saying like based off, you don't see the graph, or they're not crossing at exactly whole number or integer values like this one was, you may have to solve them algebraically. All right, and then one more. We have f of x equals x minus 2 squared plus 1. So Once you copy the problem down, take a moment, just write how it's going to open, and then where the vertex is going to be. All right, what do we got? How's it going to open? It's going to open up, and then our vertex would be 2, 1. Positive 2, positive 1. Yep. All right, so once we know that, again, make your x and y axis. You're going to go right 2, up 1. And we know it's opening upward now. So as we think about our table, okay, we're going to go left 1 and up 1, just like the table says from our vertex. And then I go right 1 and up 1. So you have a mirror image point. And then we'll go left 2 from the vertex and up 4. So here's our vertex, left 2, up 4, and then the mirror image, right 2 and up 4. So our axis of symmetry, if we needed to say the axis of symmetry, is just x equals 2. Remember, it's always x equals the h value. We can look at the graph to get our y-intercept. So where would our y-intercept be? Just looking at the graph. 0, 5. Now, we don't see it crossing the x-axis. So let's see why it wouldn't cross the x-axis, or why there's no x-intercepts. So if I plug 0 in for the y, or 0 in for the f of x, we can solve and see why we're not getting any x-intercepts. So again, I'd be doing PEMDAS backwards, so I can subtract 1 here. That would give me x minus 2 quantity squared equals negative 1. Again, I'd want to try and undo that square with a square root. So what happens when I try to square root the negative 1? Remember, there's no real numbers. This is where we did imaginary numbers in the second quarter. So there's no real roots in this case. That's why it's not crossing the x-axis. Or no real x-intercepts, we can say. All right. From there, I will put the homework up in a moment. All right, your homework's 359, 360. It goes on to page 360 also, 1, 3, 9, 11, 17, 19, and 25.